Hello, before we start this video about fundamentals of chemistry, we would like to apologize for the amount of typos and lack of spell check in this video.
Welcome to an introduction of chemistry, where we will explain how everything in chemistry is somehow connected. To make it simpler, we'll follow the course of some elements. Elements are defined as a substance with only one type of atom. Atoms, which are the building blocks of everything, consist of subatomic particles known as protons, which are positively charged, neutrons with no charge, and electrons, which are negatively charged. One of the elements are chlorine. Its chemical symbol is Cl. The atomic number, or Z, of Cl is 17. This means it has 17 protons and, of course, an equal amount of electrons to balance the charge. The relative atomic mass, or AR, is 35, which is the average weight of a Cl atom, whereas the most common isotope is 25 Cl, meaning that it has 17 protons and 8 neutrons. All elements are cataloged in the periodic table. It consists of 8 vertical groups, which tells us how many electrons are in the valence shell, and 7 horizontal periods, which tells us the amount of shells in an atom. See more about the periodic table in Group 2 video. The shells are separated into subshells, S, P, D, and F, where each subshell has an X number of orbitals. The electronic configuration of Cl is 1s2, 2s2, 2p6, 3s2, and sp5. This also makes it easier to find the element in the periodic table. See Group 3's video. All elements want to have a full outer shell. Chlorine only needs one more electron to fill its outer shell, which makes it highly electronegative, the ability to gain or lose electrons, which you can learn more about in Group 5's video. Because of the high electronegativity, it can take an electron from atoms with low electronegativity, such as sodium or Na. This will make the sodium a positively charged ion, or cation, and chlorine a negatively charged ion, or anion. These two will attract to each other to form an ionic bonding, sodium chloride, or NaCl, known as table salt. These ionic structures build 3D networks known as ionic lattice structures, or crystals, which you can learn more about in Group 8's video. Another aspect, effective nuclear charge, is the net force of attraction exerted on the outer shell electrons, accounting for what is known as a shielding effect. Learn more about that in Group 5's video. Because Cl is so highly electronegative, it can share electrons with other highly electronegative atoms. These bonds are called covalent bonds. See Group 7's video. They have a lower ionization energy than ionic bonds, which means that the bond can break easier. A phenomenon that occurs in covalent bonds is polarity, the uneven distribution of electrons creating a positive and a negative charge within the molecule. This is because of the difference in electronegativity, which means that some atoms are drawing the electrons closer to its nucleus, and the atom gets a slight negative charge, while the other atoms in the molecule remain slightly positive. Common example of this is hydrogen dioxide, known as H2O, which is water. A polar bond is an intermolecular force. Water molecules are hydrogen bonds. There is a variety of dipole forces, or intermolecular forces, which are collectively known as van der Waals forces. See Group 6 video on this topic. Copper, which is a metal, forms metallic bonds. This means that the atoms let go of their electrons, forming an electron cloud around the cations of copper, holding them together, giving it properties such as thermal and electrical conductivity. Carbon-12 is a special isotope of carbon. Mole is a quantity of atoms following the base SI unit known as Avogadro's constant, the amount of atoms in 12 grams of carbon-12. See more in Group 10's video. You can also use moles to calculate concentration, titration, and duration. See more in Group 11's video.